In this lesson, we're going to examine two ideas. We're going to examine, first of all, the midpoint of a line. Okay? A midpoint of a line refers to the coordinates of the dot in the exact middle of a line. So if I had a line, and I knew the endpoint, and I knew the other endpoint, and I wanted to find the middle, really, I can find the average of the two ends. Okay? To find an average, we add up what's happening over here plus what's happening over here, and we divide by 2, the halfway point. So our formula, and this is our first formula for this unit, is x1 plus x2 over 2 and y1 plus y2 over 2. Notice they're in brackets. There's a comma between them because I want to form a point. Okay, so take a look at some examples. The coordinates of the midpoint of the line segment that joins these points. So let's look at the diagram here for the first one. A is 0, 0. B is 4, 0. 1, 2, 3, 4. It's over here. Common sense says the middle of this line should be right about there, right? Oh, I counted that wrong. 1, 2, 3, 4. Right there. B. Common sense says the middle should be right there. Well, if I try the formula, and we're going to use this symbol MP for AB. So midpoint of AB is 0 plus 4 divided by 2, comma, 0 plus 0 divided by 2. Put the equal sign in the wrong spot. Right there. All right, what do I get? I get 4 over 2 and 0 over 2, which comes out to 2, 0, which is that spot right there. Now, I don't know that I really need a formula for that one. That was a pretty easy calculation, but the formula works. If we try the next one, F and G. 0, 2 would be right here. That's F. And G would be 1, 2, 3, 4, 5, 6, 7 down here. So the midpoint of the line that joins those, if I draw the line, should be somewhere, I don't know, right about there. Yeah, it's a little bit trickier to tell because I got something above the axis, something below the axis. I could count backwards using, like I can go this way and this way at the same time and figure out where the middle is. Or maybe use the formula. So F and G, below G here, okay? 0 plus 0 over 2 and 2 plus negative 7 over 2. Notice I'm adding the negative. So I'll get 0 over 2 and 2 plus negative 7 is negative 5 over 2, which gives me 0 and negative 2.5. So the actual middle is, I was pretty close, right there. Again, that probably wouldn't be too hard to count because I'm on the axes. But let's look at the third one. The third one is negative 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Up here, that's M. And 8, negative 1. That's N. Where is the middle of this line? Well, that one's slightly more challenging to find because it's going on a diagonal. This is really where I want that formula. So the midpoint of MN is negative 3 plus 8 over 2 and 7 plus negative 1 over 2. That's going to give me 5 over 2 and 6 over 2. Notice when I add 7 plus negative 1, it's like saying 7 minus 1, right? Which gives me 2.5 and 3. On that is about there, which, yeah, that length looks about the same as that length. But the formula made my life a lot easier to calculate. So all we're doing is averaging endpoints. Just be careful with signs. In particular, something like this last one here where I had to add the negative, it actually ends up subtracting, right? Okay, the first idea, midpoint. Let's do some problem solving. Let's do some thinking with this midpoint. We know what it is. We know how to calculate it. What if I want to work backwards? So one of the endpoints of a line segment is 1, 1. The midpoint of the line segment is negative 3, 2. Find the other endpoint. So my suggestion here is when we're not so sure about something, especially throughout this unit, let's draw ourselves a picture. That could be helpful. Everything we're dealing with is on the Cartesian plane. So if I draw it out, I might get some ideas. So 1, 1, x is right about there. That's an end point. Negative 3, 2 would be about here. That's y. Negative 3, 2. Oop, not negative 2, positive 2. And that is the midpoint. Well, if that's the middle, and x is the endpoint, then the line must be going this way, and z must be over here somewhere. So how could I find z, the other end? So there's two ways you can go about doing this. Method number one is let's use that formula. Our formula, our midpoint, equals x1 plus x2 over 2 and y1 plus y2 over 2. Move this stuff right out of the way here. What do we know? We know the midpoint. The midpoint is negative 3 and 2. We also know one of the values. We know one of the x's is 1, but I don't know the other one. So I'll put an x in there. I know one of the y's is 1, but I don't know the other y, so I'll put a y in there. And then I'm going to solve this. Now, I look at this and I say two different equations. I see one about x's. This is an equation. Negative 3 has to equal 1 plus x over 2. And I know that the y's come from this piece. So in other words, 2 equals 1 plus y over 2. And I know I can solve both of these in the same manner, they look kind of the same, by cross multiplying. So negative 3 times 2 is negative 6, and 1 times this stuff is just that stuff. So I can solve this and say, oh, x is negative 7. If we do the same thing for the other one, I'll cross multiply. 2 times 2 is 4. 1 plus y. 4 minus 1 is y. Hey, y is 3. Well, then I found the midpoint. The midpoint, z, has the coordinates negative 7 and 3. And that would totally work. And if you like formulas, use the formula. Totally going to work. But if you don't like formulas, and you like to think a little bit, let's look at a different way. If we go back to the question, in particular the picture, and I say, well, this is an endpoint, this is a midpoint, that's the other endpoint, and they're joined by a line, well then, doesn't this line have a slope? So can't I count up and over? In other words, up 1, left, I have to go over 1, 2, 3, 4. Well, that pattern, up 1 and left 4, has to happen over here too. So if I go from negative 3, 2, and I go left 4 from negative 3, subtract 4 from that, we get negative 7. If I go up 1 from 2, I get 3. And that's the exact same answer that I had for z by using the formula. But I did it by using the idea of a line, in particular, the slope of that line. Okay, so a little bit of problem solving there. Okay, that's idea number one, midpoints. Idea number two, something we call a median. There's a bit of writing here, so maybe you printed off the lessons you can look at. We'll talk about it as we go through it. But a midpoint is a line that joins a vertex of a triangle. So a vertex is the point, the corner of it, to the midpoint of the opposite side. So if this is my triangle, I'm going to call it A, B, and C. Well, then a median, the red one, would go from A to the midpoint of BC. That's what that line is there. The green one would go to the midpoint of AB. And obviously the blue one would go to the midpoint of AC. So our objective today is going to be trying to find the equations of these lines. And to do that, well, the first thing I need is I got to figure out where it starts and ends. I will be told in the question where to start it, the median at A. So the thing I need to find first is the midpoint of the opposite side. That way I know where to draw my picture. Once I do that, once I have 2 points, coordinates and coordinates, I'm going to need to find the slope. So that's going to be step number 2. And once I know the slope, I'm going to have to find the y-intercept using a point on the line. And we're going to know too, either the vertex or the midpoint. And as I said, these are called medians. And just to point out, and we'll talk about later, where medians meet, they always meet in the same spot. It's called the centroid. All right, so here's our big question for today. So given the triangle with vertices A, B, and C, let's sketch it. And then we're going to draw the medians and find their equations. So let's draw it. We need a Cartesian plane to start. 2, 5. A is 2, 5. So we're going to rough sketch here. A is 2 and 5. I would suggest use the yellow stickies. B is 6 and negative 1. And C is negative 4. and negative 5. And I want to sketch it so I get an idea about my shape and how accurate my math is. Okay, so there's part A done. Part B, draw the median from A. So I know it starts at A, but I don't know where it ends. If it starts at A, it has to end at the opposite midpoint. Start at A, end at opposite midpoint. The opposite midpoint would be the midpoint of B and C. But I don't know that yet. So step number 1, find the midpoint BC. We can do that. We've learned about midpoint today. Midpoint of BC, I got to take B and C, add them together, divide by 2. So negative 1 plus negative 5 divided by 2. Let's do our math here. We'll get 2 over 2 and negative 6 over 2, which comes out to 1, negative 3. Okay. 1, negative 3. That's about there. Midpoint B, C. I can draw the line now. I know where it starts. I know where it ends. So I've done the first part. I've drawn it. Now I have to find its equation. Well, we've talked about equations. Equations need slopes and intercepts. So step number 2 is let's find our slope. Our slope from where I started, which is 2, 5, to where I ended. We said that was 1, negative 3. If I have 2 slopes, or sorry, 2 points, I can use my slope equation. Don't forget our slope equation is y2 minus y1, x2 minus x1. So let's do that. So we're going to do 5 minus negative 3, so I did the y's, over 2 minus 1. And what's that going to give us? 8 over 1, which is just 8. Hey, I got myself a slope. Good news. But for an equation, I need a slope and an intercept. So I've got to find that y-intercept. We do that by filling, oh, not 3, 8. We do that by filling in what we know. In order to get b, I need an x and a y. But the good news, if I go back to my picture, is I've got 2 of them. I've got the starting point, and I've got the ending point. Your choice which one you want to use. I'm going to use 2, 5 because they're both positive. I like positive numbers. So 5 for y and 2 for x. And then we're going to solve. This goes back to what we did yesterday when we learned about, or we reviewed solving equations. I said we're going to need to be able to do them. Here's the equation of the median from A. Okay? Not tons of steps, but there's lots of things to remember as we're doing this. Okay, we're going to do the next one. Actually, you're going to do the next one. Draw the median from C and then find its equation. So if I'm doing the median from C, I know I have to start at C. But I have to figure out where to end. So I start at C and I end at the midpoint of the opposite side, which would be the midpoint of A and B. Oh, I don't know that yet. I better find it. All right, so step 1, midpoint of A and B. I'm going to go way down here at the bottom, okay? So we're doing part C. I want to find the midpoint of A and B. So we're going to take our coordinates way up here at the top, add them together, divide by 2. That's all we're doing. Okay. Hopefully you printed those off so you don't have to go up and down, or pause things. So AB. So we have 2 plus 6 for our x's, and 5 plus negative 1 for our y's, which comes out to 8 over 2 and 4 over 2, or in other words, 4, 2. Okay, there's my midpoint. 4, 2. 4, 2 is about over 4 and up to right about there. That's the midpoint of AB. 4, 2. So now I can draw my line and where it goes, right there. I want to find the equation of that line. So I've got a starting point. I've got an ending point. I can find the slope of that line. Let's go do it. So our slope, and I'm just going to write down the coordinates right here. C was negative 4 and negative 5. So we're starting here and we're ending here. I want to find the slope of the line that does that. So 2 minus, back to the blue color there. 2 minus negative 5 and 4 minus negative 4. That's going to give us 7 over 8. Oh, fractions. Nothing wrong with fractions. You like fractions? Totally fine. If you want to change that to a decimal, you could do that. I'm going to do the question in fractions. But if you want to do it in decimals, that would work. Don't round the decimal, though. Keep all of it, 875. If it came out to a decimal that was messy, 0.33333333, you would have to do it in fractions, okay? I'm going to do it in fractions just so we know where things are coming from. So, what do I know? I know my slope, mx plus b. To find b, I need to use a point, but I know 2. I know the start, I know the end. I'm going to use the end because they're nice small numbers and they're positives. So, 2 for y and 4 for x. Okay, I know with fractions, I multiply straight across, so I'll get 28 over 8. I know if I want to solve this, I've got to bring the number over to the left-hand side. I also know with fractions, I need common denominators. So I need to make these both into 8s. Okay, I got to times that by 8, which means I got to times that by 8, which gives me 16. And if I subtract them, I get negative 12 over 8, which reduces to, divide both by 4, negative 3 over 2. So the equation of the median from C, y equals 7/8 x minus 3 over 2. Or if you use decimals all the way through, 0.875x minus 1.5. Okay. That's our big idea for today, being able to find a median. Okay. And incorporates a midpoint, but also incorporates finding the equations of lines like we did yesterday. Okay, last one, last idea, word problem. How do we apply some of this stuff? So, a waste management company planning to build a landfill in a rural area. To balance the impact on the 2 closest towns, the company wants the landfill to be the same distance from each town. On a coordinate map of the area, the towns are 1, 8, and 5, 2. Describe all the possible locations for the landfill. So when in doubt, let's draw it out. What do I know? Town A is at 1 and 8. Town B is at 5 and 2. Where should we put the landfill? Our common thought here is, where should we put that landfill? Well, the landfill, most people want to put it, well, let's put it right in the middle. And that would totally make sense. The middle, the midpoint of AB, is 1 plus 5 over 2 and 8 plus 2 over 2. So we got 6 over 2 and 10 over 2, which is 3, 5. That would make total sense. Yeah, put it right there. But the question said, describe all the possible locations. So we have to stop and think here for a second. Is that the only place I can put that landfill? Or would it be fair to maybe put it up here? Because the distance this way is the same as the distance this way. Or maybe it could go here, because that distance is the same as that distance. Or here, or here, or here, or here, or here, or here, or here. Or in other words, anywhere along this line. I think that would make sense to put it anywhere along that line. So when it says all the possible equations, I need to figure out the equation of this line. In other words, I need mx plus b. So I need to think about, how can I get the slope of that line? I don't know any points except the midpoint. I do know that. So 35. That's the only point I know on that line. So I can't necessarily use y2 minus y1 over x2 minus x1 right now. I only know one point. So I need to take a big leap of faith here. Here's my idea for you. If I were to find the slope from A to B, what do I notice about the two lines I just drew? I notice that they are perpendicular to each other. And I know things about perpendicular lines. I know that they are negative reciprocals. So if I could find the slope of AB, which I can totally do because I know A and B, so I can do y2 minus y1 over x2 minus y1, or x1, I get a slope of negative 3/2, which tells me for the red line, the line I really want, the perpendicular slope, I can find the negative reciprocal. It's 2/3, which I can then use to find the equation of the line. Because now I've got a slope, and I can find b because I know a point. 5 for y, 3 for x, solve for b. Okay, so I do my fraction idea here. 6 over 3, which comes out to just 2. 5 minus 2 is b. b is 3. So the equation of that line, the red line, the one I want, where the dump could be anywhere along it, has the equation y equals 2/3 x plus 3. Okay, and that's a bit of a tricky idea. It's not a median. It's not going from a vertex of a triangle. It's a different kind of line. But it's one that involves midpoints again. Midpoints are really helpful tools for finding lines, whether medians or this line. Okay, that's it. There was a lot of stuff in that lesson. Okay, the first couple of questions are just simple midpoints. Then there's a couple of applications of medians, and number 14, I believe, is something like the garbage dump question where you have to apply your thoughts a little bit. If you're stuck, come see me. We're going to keep on moving. This unit kind of goes a little bit quick, and there's lots of formulas, so you kind of want to stay on top of things.